So for me, it's good morning. For you, hopefully it's probably good afternoon. Hopefully you're not watching this while you're driving or anything reckless like that. Make sure when you sit down to take these notes, you are sitting at a computer, you have some paper and pencil. If you want to, you could have printed out the PDFs of this so that you can follow along as we do these problems. Um, so let's go on. 2.6, linear inequalities in two variables, example 1. So what we're going to do here is instead of talking about equations like we have been, we're now going to talk about inequalities and how to graph inequalities and how this works and how do I know a good solution. So we're going to work on some of this and see what it turns out to be. So check whether the given ordered pairs is a solution to 2x plus 3y is greater than or equal to 5. What you do, remember this is my x, this is my y, so I plug them in for x and y. 2 times 0 plus 3 times 1, is that greater than or equal to 5? And I want to put a question mark because we want to find out if that's true. 2 times 0 is 0. 3 times 1 is 3. So this is 3. Well, 3 is not greater than or equal to 5. So letter A, this is not a solution. It does not work. 3 is less than 5. It's not greater than and it's not equal to. Let's try another example. Here we go. 2 times 4 plus 3 times negative 1. Is this greater than or equal to 5? 2 times 4 is 8. Fix that, 8. 8. 3 times negative 1 is a negative 3. Is that greater than or equal to 5? Well, that is exactly 5. That is equal to 5. And since I have equal in my inequality, yes, this is a true statement. Is this a solution? Yes, this is a solution. All right, well, let's try my third example, 2, 1. So again, it's 2 times 2 plus 3 times 1. Is this greater than or equal to 5? 2 times 2 is 4. 4 plus 3 greater than or equal to 5? Question mark. 7 is greater than 5. So yes, this is also a solution. So I can have answers that are less than, answers that are equal to, answers that are greater than. Since I'm looking for greater than or equal to, letters B and C were my answers. How many solutions are there to this inequality? How many different ordered pairs can I plug into this and come up with an answer? Well, technically speaking, there's an infinite possibility of answers, not sideways 8, an infinite number of possible answers when we come to this. You can see more of this when we get to the graphing in a little bit, and I'll talk more about what the solutions, what the answers could be. Let's try the next slide. Graphing a linear inequality. Step 1. Graph the boundary line of the inequality. Assume that it's equals and solve the equation the way you would normally solve an equation. But when you go to graph that line, if there's no equal sign, if I have just less than or just greater than, I want a dotted line just like this. But if it is greater than, less than or greater than, less than or equal to, greater than or equal to, I want a solid line just like this. Step 2, test a point on either side of the boundary line to determine the appropriate side to be shaded. We could actually just test one. There's some ways you can look at the graph and kind of decide which is which. We'll talk about this in a little bit. So let's actually try an example. Graphing linear inequalities in two variables. Y is less than 2x. Well, this looks like it's in slope-intercept form. Y equals mx plus b, and I'm thinking of equals right now because I want to graph the line. My slope is 2 over 1 because it's a 2, but rise over run. I want 2 over 1, so I have a run. My b, well, there's nothing there, so that tells me that 0, 0 is my starting point, my initial value. So I start at 0, 0. I rise 2, run 1, rise 2, run 1, rise 2, run 1. I can also, instead of rise and run right, I can fall and run left, fall and run left, fall and run left. These are all on the same line. Now I'm going to go and choose a line to draw, but I need to decide, do I want a solid line or a dotted line? I want a dotted line. Why do I want a dotted line? Because purple is spiffy? No, because there's no equals up in this original problem. It's y is less than 2x, not y is less than or equal to 2x. So I need a dashed or dotted line for my equation. Remember, whenever I have lines, I need to put arrows on the end. At this point, I need to think of what is less than this line. If I think of what's less than this line, you can see that it's numbers that are below this line that are less. Now, how that kind of works, there's nothing wrong with doing it that way, but what if that doesn't make sense to me? Well, I can always test a point like I just did on those first 3 points. Pick a point, any point. I'm picking the point 2, 0. Plug it into the inequality. Y is less than 2x. Is 0 less than 2 times 2? Yes, 0 is less than 4. That is a solution. So that means the side of the graph where this point is my solution. This is less than. All of these points, let's get something more spiffy. You got to love the word spiffy. This is more spiffy. Any of these points are my solutions. So there are infinitely number of solutions. Anything in this area will make this statement true. So this is my solution. Now what about the points exactly on the line? The points on the line itself, like this point right here, this is the coordinate 1, 2. This will make this equals. So if I said, instead of y is less than 2x, I said 2, is this less than 2 times 1? No, this is not less than 2 times 1. This is equal to 2 times 1. So any point that is on the line is not a solution. That's why it's a dashed line. That's why it's not solid, because those points are just the boundary. They're not actually part of my equation. So let's try another example. 2x minus 5y is greater than or equal to 10. I could solve this for y. I could put this in slope-intercept form and graph it. Or I can do what we did in the last notes and find my 2 intersection points, my x and y intercepts. So to find my x-intercept, I let y equal 0. To find my y-intercept, I let x equal 0. So let's solve these. So 2x minus 5 times 0 is it, well, again, you want to start with equals to find the line. When is this equal to 10? Well, 5 times 0 is 0, so 2x is equal to 10, so x is equal to 5. So my first coordinate is 5, 0. So I'm going to put a dot at 5, 0. Well, let's find my other coordinate. My other coordinate, I said let x be 0. Again, use equals. This becomes 0, so negative 5. Y is equal to 10. Divide both sides by that negative 5. So y is equal to negative 2. 0, negative 2 is this point down here. Now I look back at my original inequality. Does this have an equals? Yes, it's greater than or equal to. So when I draw my line, I want a line that is a solid line. Okay. And that's what my line looks like. That's my boundary. Now the question is, do I want points that are above this or points that are below this? Well, this is where we pick a point and plug in. On my last graph up here, I pick the point, oh, I covered it up, the point 2, 0. It was right here. Let me do that in blue. I picked this point right here, 2, 0. I tell you, the easiest point to pick, however, is the point 0, 0. On the graph up at the top, 0, 0 was actually on my line. So I wasn't 100% sure if that's not going to give me an information of above or below the line. But here, 0, 0 is above the line. So this is going to tell me if above the line is what I want or below the line is what I want. So 2 times 0 minus 5 times 0. What is this greater than or equal to 10? Well, 2 times 0 is 0. 5 times 0 is 0. 0 minus 0 is 0. 0 is not greater than or equal to 10. So I don't want what's above this line. I actually want what's below this line. This is the information that I need for this graph. Now you're going to look at this and you're going to say, hey, wait a second. I wanted to go ahead and, wrong button. You said this was greater than, so shouldn't I be just doing what's greater than the line? Well, that's the thing. I don't necessarily want exactly what this says, because if I solve this for y, I'd have to divide by that -5, and this sign would change. So I have to be very careful and not just guess at what it looks like. Rather than, I need to plug in a point. Here, the point 0, 0 is my point. 0 is not greater than 10, so I need not the top, but what's below. Don't let what the graph set, what the inequality say, determine what's up above or below. Sometimes that will work, but like in this case, it doesn't always, so be careful. Graphing linear inequalities in one variable. Y is less than -2. Whoa! Well, I have an XY table. I have an XY coordinate plane. What does this mean? Remember, when I have y is less than, this is really y is less than 0x minus 2. I have a slope of 0. This is a horizontal line. I want a horizontal line at x equals -2. There is no equals, so this is going to be a dashed line where y equals -2. There's my dashed line. Do I want above this line or below this line? Again, I pick the point 0, 0. Plug it in. There's no x, but y 0 is less than -2. That's not a true statement. So I don't want where this is. I want the other side. And that's what my graph looks like, where y is less than -2. Now, if I look at this line and say less than, well, that should be below. Yes, for this particular graph, that works. But it won't always work for every graph, so you have to be careful. Let's look at, instead of horizontal lines, let's look at vertical lines. X is less than or equal to 1. Remember, this is undefined slope. And this is the only time I have an equation that's x equals, and this is going to be a vertical line. Well, I do have equals, less than or equal to. So I want a solid line where x equals 1. And again, don't forget to put your arrows on the end, because the points on that line are true. The point 1, 4, if I plug in x for 1, 1 is equal to 1, so that works. Now, do I want the points to the left of this line or the points to the right of this line? Some people can look at it and say, ooh, I want, and no, based off of this information. Again, you have to be careful, because like on the two problems ahead, or previously, you have to be careful with that sometimes. So I pick the point 0, 0. So if I plug in, well, there is no y, so plug in 0. Is 0 less than or equal to 1? Yes, it is. So I want these points here to the left, including the line itself. That's my equations. Let's see where we are. Okay, let's see how we're doing with time. Okay, well, should be under 20 minutes, easy. So here we go, last problem. Writing and using a linear inequality. We're going to actually use this based off of word problems. You have relatives living in both the United States and Mexico. Woohoo, good for you. You are given a prepaid phone card worth $50. Calls within the continental United States cost 60 cents per minute. Calls to Mexico cost 44 cents per minute. Write a linear inequality in two variables to represent the number of minutes you can use for calls within the United States and for calls to Mexico. Okay, so this is a type of problem that has a total. So whenever I have a total, it equals I want to equal the total. 16 seconds is the cost per minute in the United States. So I'm going to call X number of minutes to US. I'm going to call Y number of minutes to Mexico. See if I can scoot this over. Okay, so my total is $50. I want to spend, if I'm going to call the United States, it's going to cost me 16 cents per call. If I'm going to call Mexico, it's going to be 44 cents per call. At this point, there's no other ways I can spend this money. I can only use it, this $50, for making calls to Mexico or the United States. So this is my full equation. 0.16x plus 0.44y is equal to $50. Needed to get a calculator. Sorry about that. Okay, so now I want to graph. First it said write a linear inequality. Well, first of all, do I have to spend all $50? Could I spend more? Well, no, that's all I have. But could I spend, yes, less? So not only is this equal to, but it's less than or equal to my $50. And I can get rid of the green one because it's now all blue. So 0.16x plus 0.44y is less than or equal to $50. Technically speaking, if I want that $50, I spent $25 and I want $25 just to sit there for forever and a day, I can do that. So I can spend less than that $50. I don't have to spend it all at once. Write a linear inequality in two variables represent the number of minutes. I have my linear inequality. Graph the inequality and discuss three possible solutions in the context of real life situation. So this is in standard form. So in my opinion, it's easiest if I go ahead and solve this using x and y intercepts. So plugging in 0 for y, solve for x. 0.16 x plus 0.44 times 0 is less than or equal to 50. Again, when I'm solving this, sorry, that's a 0. I can just use equal because I want 1 point. So this is 0. This goes away. 0.16x is equal to 50. Divide both sides by 0.16. So x is equal to, I grab my handy dandy calculator, 50 divided by 0.16, I get 312.5. 312.5. So this is 312.5. We'll talk about that 0.5 in a little bit. I'm not going to focus on it at this point. Let's plug in 0 and find my y-intercept. I found my x-intercept and my y-intercept. I'm going to say 0.16 times 0 plus 0.44 times y is equal to 50. This is 0. So 0.44y is equal to 50. Divide both sides by 0.44. And I get out my handy dandy calculator. 50 divided by 0.44. I get 113.6. And if I round to 2 decimal places, 113.64. So this is 113.64 phone calls. Okay, so let's go to my graph and plot these 2 points. On my x, remember x was minutes to the US. And this, my y is minutes to Mexico. Okay. I need 312.5 minutes to the U.S. So 2, 4, 6, 8, 10. Let's go ahead and take this up to 500. So I'm going to count each other one as 100, 200, 300, 400, 500. Up here, again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. I need to get to 113. If I go to 150, I can count by 15s. So every other line is 30, 60, 90, 120, 150. Both of mine are a little big. I could make them a little smaller if I wanted to. So 312.5. Well, if this is 350, this is 300, 312.5 would be somewhere in here. 113.64, that's if this is 90, this is 105, so it's going to be right in here. Make that one red. So then I can get a line. Do I need a solid line or a dashed line? I can spend all $50, so I want a solid line. I'm going to choose black because black is spiffy. Yes, that's my word for the day, spiffy. Remember that, by the way. So here are my points. Now, can I use more than this? Can I pick a point out here and have it be true? That's going to be greater than my $50. So the points that I pick need to be within this bounded region right in here. Any points in here is going to work. Now this point right here, 160, that looks like a good point in my bounded region. 150, 15 is a good point in my bounded region. And let's go with 230. That's a good point in my bounded region. These 3 points look like they're all in my bounded region. So I wanted 3 possible solutions in the context of real life situation. So my first point, this one here, this says I'm going to use 100 minutes calling the US, which 100 times 0.16 is $16. And then I'm going to use, this point right here was 75 minutes calling Mexico. So how much is that? Let's see. If I do 75 times 0.44, that's going to be $33. If I add those up, that adds up to $49 less than my $50. So this is what I need to write for all 3 of my points. I use 100 minutes calling the US. I use 75 minutes calling Mexico. This one, I use 200 minutes calling the US, 30 minutes calling Mexico. This one, I use 150 minutes calling the US, 15 minutes calling Mexico. That's the real world solution, the real world meaning when I talk about these particular points. If you need to, if I ask, write all 3 of them out for a question, I want to save you a little time. I'm not going to write out all 3. That should be. This is a little extra problem if you do want to do one more, but we've done ones like this, so I'm not going to spend the time doing it. Bring your book to class. Your homework for today, the work in class tomorrow will be out of the book. Bring your book to class. Have a great day. We have spent 24 minutes. Sorry. Bye.